Oh, here we go. What about now?
Yep.
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 Cool. Leave that. Sit down. Sweet.
Hi guys, we'll start about 5 minutes and take some seats. We'll start about 5 minutes. Thank you.
Well, that one's reserved, obviously.
Which one? That one?
The laptop's recording.
Yeah. Sit outside the laptop.
Steve, Mitt, Steve.
How you doing?
Good.
Used
Good to meet you.
used to work with me for a short period before he fucked off somewhere else. And then
Couldn't stand the guy.
me and Steve worked at Half Minute many years ago.
Oh, yeah.
I made him redundant.
You did actually. Yeah, appreciate that. Yeah, it's good.
It was at the right time and he gave you a decent payoff.
And actually helped.
Yeah.
Yeah.
It was shorter than well, you're here, isn't it?
Yeah. Yeah, it's not saying it works out very well.
Hey guys, we can get off in a couple of minutes, so we'll take a seat.
Yeah. First one. No, second. Yeah, second.
Cool.
What's like?
Cool. Okay. Well, thanks guys for coming. We've got a great turnout for the rest so far, to be honest. So that's really cool. So my name's Sean. I'm CTO at Zoho, a specialist accounting consultancy. We're thankful for hosting us tonight. I'm going to hand over to Callum, who's going to give you the admin, TCCs, toilets, and fire exits. And then the first chat is a guy called Paul, who's from Worldpay. So Callum, over to you.
Hello everyone, my name's Callum. Didn't want to I just wanted to say welcome to Worldpay. I'm just going to talk through Worldpay quickly and give everyone a view of what we do and who we are, in case you weren't aware. So, just before we start, just a few notes that the opinions we have in today's talks are personal, not those from Worldpay. This isn't an external event. The talks are going to be streamed and recorded. And sorry, you're okay. And the fire escapes, if there is a situation occurs, if you head back towards the elevators, there's a central stairwell there. So, Worldpay, who are we? We are a acquirer, the largest global payments acquirer, and if you think of what an acquiring bank is, we're a bank which helps merchants accept payments. So we essentially set as a facilitator in between the merchants and the issuing banks and the card schemes. So when you tap your card in a shop, we'll be the ones that request the hold on the funds in your bank account, and we'll route that back to them. The terminal says accepted, and then we will collect the funds from all merchants at a later point. We also have a lot of other services which support that, like dispute management, fraud checking, and storing payment tokens for like online websites where you store your card details. And as you can see, in terms of processing volume, we do quite a lot. There's nearly $2.5 trillion last year that we covered. That was 52 billion transactions. And we were supporting over 1 million merchants globally. So when this changes, a nice map of this is going to go on. Excuse me. We're operating in sort of over 46 countries, 70 regions across the globe. We're always trying to extend to new regions and accept new payments, capture methods. So some of the well-known brands, the major brands that you might know, we'll sort of give you a review process with. I'll give you an idea of when you last had a transaction processed by Worldpay. The question we were trying to cover here is, what does an acquiring platform actually do? So I'll try and keep this short, sweet. Essentially, when you tap your card at a card terminal, we'll be routing that transaction through to the issuing bank to put a hold on the funds there, and then routing the message back through the card schemes to the merchant to say that transaction's been accepted, and you can be given your goods at the store. We try to do that as quickly as possible because people don't like to stand around waiting to spend the money. The second aspect of this is our clearing and settlement process. So that's when the first aspect was holding the funds. The second aspect is when the merchants have provided the goods and they want to request the funds. They make a settlement request into Worldpay, and we will then send those collection messages onto the issuing banks again. The issuing banks in turn will essentially return those funds through the card schemes to Worldpay, and then Worldpay will disperse those funds out to the merchants and provide them their financial reconciliation messages. So it looks sort of overly complex there, like why do you need so many steps? But effectively, we're just providing simplification of the network complexity. Like merchants don't want to talk to 1,000 issuing banks. They also don't really want to talk to tens of different card schemes. So we just provide a single point of integration for the merchants and provide that layer of simplification. So we've been around for quite a long time, 5 decades, in different forms or other, and we're sort of intending to be around for a little while longer. We're a very technology aggressive company at the moment. We're really looking to forward our technology to serve the platform, which is what Paul will be to later. But if you want to join us on that journey, we are hiring, so talk to us afterwards, get a feel for the company, and visit our jobs boards later on. So I hope you enjoy the talks and have a good evening.
Good evening, everybody. My name is Paul Metcalf. I'm the warm-up act for Sven at Confluent. We'll be on later on. What we want to talk about tonight is just to give you an understanding of Worldpay's journey with Kafka. And I was involved in one of the first systems to be developed for Worldpay around Kafka, and that's what this story is about. So we have to start. Obviously, we've had the health warning about what we say in opinions and all that sort of stuff. This is the security one. So obviously, we've had to change one or two screenshots and bits and pieces that appear later on, for obvious reasons. So back in 2021, we were handed a business requirement to build a new multi-platform system. And some of those systems they wanted connected were internal in our data centers across London. Other systems were actually Worldpay. Some of them were actually out in the States. And all they had at that time was an idea about what the product set was going to be, going forwards. The enterprise architects looked at it and said, great idea, let's use Kafka. So, okay, Kafka is going to be the backbone, which is absolutely fine. Platform should be high resilience and high availability, as we always have in Worldpay. And unfortunately, the support structure is unknown. So we don't have any way of supporting it going forward. And incidentally, the production platform needs to be live for 6 months. So, interesting challenge. At that time, back in 2021, there was little experience of Kafka and Worldpay. That was the starting point. We didn't have any environments except for a couple of developer POCs in one of the cloud hosters, which is Instacluster, and who we are still dealing with on a large basis. We didn't have any agreed functional requirements for the system, which is actually a bit of a problem, as I'll come on to later on. As I said, no support teams. So once we built the system in 6 months, how do we support it? How do we get the thing live? And our enterprise architecture were a little bit interesting. They gave us a strong steer, but only on what not to use, which is kind of an interesting way of doing things because they normally recommend what we're supposed to use, not the other way around. What we ended up doing was using that to reduce the number of options we had going forwards. So there's the quick timelines. Starting mid-November 2022, and going on from there. So the connected systems I was talking about earlier on, these locations, and as you can see from the screen there, they're distributed all over the place. So some in Manchester, some in London, some in the States, but also an important point here is that we use a lot of external systems. Okay, we use external sales systems. If you're actually in financial services yourselves, you'll understand the idea of customer due diligence and things like that. So those external top-tier companies that actually deal in that sphere, we also integrate with, and they're external. So from our point of view, we had to integrate external systems and so on. So where do you actually locate that system? Okay, where do you build the Kafka platform, right? So Kafka itself is relatively easy to build, and if you're a developer, you can spin it up in 5 minutes with a Docker image, which is absolutely fine. But if you want to build a production platform, where do you build it? Okay, so where we started from was trying to come up with the locus of all of those circles there and actually figure out what was the ideal place. Now, when you look at what Kafka needs, it needs connectivity, it needs security. All of those are different across all of those different domains. So when you're building a hybrid platform, it's easy to look, in depth straight away at the Kafka technology and forget all the other bits and pieces around it. We had to know what to build once we'd actually established where we were going to build it. And the trick in our business is to actually understand what the minimum is that you can actually build. The challenge that Worldpay has is that we have a large number of very sophisticated technology teams, okay? And they all do things slightly differently. Some use development environments, and just development environments and then spool that through a pre-production system into the product. Other teams use a whole bunch of environments. So we came up with this list of all these environments that had to be built. Obviously remembering that we're talking about 6 months here, guys. So we hadn't got a development environment, we need all the other bits and pieces around it as well. So when we looked at where we could build, obviously the number one choice for us would have been on-prem hosting. Problem is that our development teams and so on keep the on-prem hosters very, very busy. And they have a 6-month waiting time to even start. So the on-prem hosting was not really an option. We had existing relationships with Instacluster, as I say, we still do. They're a good organisation, and I'll come on to those in just a second. As you can see, we have some familiarity with them. They provide all the products that we need, Kafka, Cassandra, schema registry, and so on. And they have internet connectivity, so we can reach out to them in any of the number of environments that we have. The bottom one, Azure. Azure is kind of an interesting one for us. At the time, we had been acquired by FIS, and so we were actually a hybrid organisation. FIS themselves have a huge investment in Azure technology, and most of their cloud platforms are hosted in AWS, in Azure rather. And so therefore, because of that, we could have used them, but we weren't 100% familiar within the Worldpay sphere with that platform at that time. Also, the Kafka offering for Azure at that time was very, very young. Confluent Cloud, I mean, there's not a lot I can say, especially with Sven sitting there, but you know, the reality is Confluent are one of the industry leaders when it comes to Kafka and all those products that sit around there. So for us, that was potentially a good option. It supplies all the products we need, and it's got inter-cloud connectivity question mark. So that's one thing that we need to look at the time. The last one was AWS at the top there. We have familiarity with AWS. We've been building there for years. We have many, many teams working in AWS. We have very high speed, very secure links into AWS. So it seemed like a good bet, but obviously, there were other things to consider. When we looked at all the options, the challenge that we have with Instacluster is that the way that Instacluster at that time managed their platform was that they had support teams that actually SSH onto your platform that sits in your account, and they support stuff up using their automation and the rest of it. But the reality is, their guys have had access into our platform using SSH. Now, obviously, bear in mind, this is a hybrid platform. So we've got on-prem systems connected into it. We've got other external vendors coming into the platform. If we've opened that part of the platform up with general connectivity, you can imagine what the picture was. And security took one look at it and said, not going to happen. Now, in fairness to Instacluster, they have now changed the way that they support. And so, if it was a discussion today, it might be a different answer. Azure, as I kind of suggested a second ago, wasn't familiar for us. We looked at it. Unfortunately, at that time, didn't have express route connectivity back into our DCs. So we would have had to spun that up, and just the connectivity piece would have taken us outside the time window. So yeah, no chance. So Azure got ruled out. Now Confluent is an interesting one. Okay, so we looked at that, and we were interested in using it. Quick and easy spin up. And as I'll come on to in a couple of slides' time, we looked at them for a number of different things. Historically, with Worldpay, and I have to go back historically on this one, probably several years, we got involved with a rather large software vendor. And that software vendor supplied us with all of the software from the middleware stacks, the web stacks, the database stacks, and all the rest of it, which is absolutely fine because it integrated, it kept a lot of people employed, which is absolutely fine. The downside of it was when it came to licensing time, there was a very, very big bill on the end of it. So there was a move away from what we would class as a vendor lock-in at that time. Now, the reason that's relevant for Confluent is because when the enterprise architecture guys looked at Confluent, they were happy that the products that we could use suited what we needed to do. Absolutely fine. But what their concern was that if the developers went off script and actually started using products that they weren't supposed to, we would end up being locked into things within the Confluent cloud. Because the added value service they do offer are quite superb. And the linking, for example, of schema registry back to the Kafka clusters and other things like that, that was absolutely fine, but we didn't want a vendor lock-in scenario again. So we ultimately ended up discounting Confluent at that time. Not entirely, I'll come on to that in a second as well. So the end of the story was AWS, that's fine. At that time, MSK as a platform was just on the horizon. It was an attractive option, as I said earlier on, because of the hosting options and our familiarity with it. And I'm going to leap into this one, or I probably shouldn't do. The reason this one is on the screen is because in the where to build question, you have a hybrid platform. And if you've got a hybrid platform and you've got some systems in your DCs scattered around the world, and you've got to connect them to a Kafka cluster, you've got to understand, unless you're using REST gateways, of course, that Kafka uses its own network protocols. And if it uses its own network protocols, then when you start talking about DR and cross-regional routing and things like that, you've got to be sensitive to this, and it's not an easy question. So one of the things that I'll come on to a bit later on is essentially driven by the fact of the wire protocol. So we decided roughly where we were going to build it. We decided some of the things that we wanted to avoid, and the problem we had was, how do you size it? Okay, how do you size a Kafka cluster? Okay, so there are obvious things, you know, how many messages you can put in, you know, what's your average TPS, all that sort of good stuff. You know, what are your topics going to be? You know, how many? What's the read and write rates on those topics? You know, what's the producer and consumer counts? Where is the traffic coming in from? What's the speed of the traffic? There are a number of different metrics that kind of go along with that. And the problem was we had no model that would actually work, no model at all. So what we decided was that ballpark sizing was good enough at the outset, and that's all we had. So what we also hadn't figured in, which is why the bottom one appears there, is that when you consider the backup approach, how do you back up your Kafka clusters? Okay, there are various ways of doing it, obviously, which we'll come on to later on. But at that time, bearing in mind my first slide, the level of Kafka expertise in the organization was low. That was a question we actually couldn't solve easily. In terms of sizing the platform, we looked at a couple of different models, and this is one from Confluent. And it's one of the most sophisticated models I think we've actually seen. It actually runs through with a web form. You enter your details for a variety of parameters, and at the end of it, it spits out nice cluster sizing. It's actually a good model, and we've actually validated some of our later platforms using that model again, and it seems to be good. And the one that you can see on the left there, that left-hand column, gives the cluster size of the system that we were sizing at that time, and it's pretty close. You know, it's a 4-node cluster, but in actual fact, being able to 3-node cluster. You know, it was pretty close in terms of the sizing of the machines and so on, but it also sized other things which we weren't interested in. So it's really trying to understand what it was that we wanted to pull from those models. The second model we looked at was ours. It's a spreadsheet. You download it from the MSK website, away you go. The challenge with that one is that if you're new to Kafka, understanding some of the terms that they refer to and some of the input parameters can be a little bit of a lottery, I would say. Some of the advanced parameters at the bottom, we didn't understand at the time the significance of, which we do now. So what we ended up with was, once again, an approximate size. So what we realized was the only way we could actually start was to size small and grow big. Only way to do it. First thing we had to do was build out development. Okay, we're going to build out development. What are we going to do? So having selected MSK in AWS, we then decided immediately if we did MSK for all of the development environments, all the pre-production, all that sort of new stuff, it was going to be way too expensive. It's an interesting service, but it's an expensive service. So what we ended up doing was actually spinning up local development environments in AWS simply on EC2s. Okay? And we deployed the software, as you can see there from the symbology. You know, we had Kafka, we had Cassandra, because that was required as well as schema registry. And the whole thing, all the tooling, was spun up in 4 weeks. Automated tooling so that we could replicate it, spin up as many development environments as we wanted. And as you'll see from the right-hand side there, it was immediately connected to Transit Gateway, so it was accessible from all of our systems internally. That was an important thing. We built integration testing in a somewhat similar manner, not quite the same, but somewhat similar manner. MSK at the top this time, not native Kafka. And it's worth saying, one of the reasons we selected MSK for this platform is because it's as close to native Kafka as you can get. There aren't any of the sophistications that you can get with Confluent Cloud. It's literally basic Kafka. And the nice thing about that is that if we wanted to lift and shift later on and move it to another hosting provider, we could do that. So we had all of the spin-up routines and software for the cloud environment, but we could move it if we needed to. So the timelines here now show where we've moved on to. We took about a month to get on to having development available, all spun up, and then to actually have that first integration test environment together. Now at this point in time, the development teams still hadn't caught up. So we had some development teams that were very quick off the mark. They were able to adapt very quickly, notably the Java ones. But the .NET teams actually were having a problem getting their libraries and bits and pieces together to try and actually join the party. So that actually continued, as we were saying, into January and then February. And obviously, when you look at the timeline, actually to deploy in April, you've got to have your applications up into system test in February. One of the things that we didn't realise at the outset was how the structure of the data and how the data is displayed on the platform actually would affect the sizing of the clusters. Okay, there were no non-functional requirements, and there wasn't an agreement at that time on what the schema definitions were going to be, what the topics were going to actually be loaded with. You know, there wasn't the agreement in terms of the base sizing, in terms of partitions and so on for those particular topics. So there was a lot of bits and pieces related to the data. And obviously from a system sizing perspective, which primarily I'm interested in, the broker retention, that's a big one. Now, to give you some examples, and we've got some people in the audience, so I won't point them out because they might be off the Christmas list. But the stuff that they're actually doing at the moment is actually huge. Okay, they're running 6,000 TPS with 10K message sizes. Now, when you look at the broker storage of that, it's huge. By comparison, the first system that we did was running 100 TPS with a 1K message size. So when you're actually designing the clusters and you're looking for where do I size them, where do I cite them, what the storage has to be available, what you can push into the topics is hugely important. I mentioned earlier on the operational side. The operational side should not be left till the last minute. Okay? One of the things that our operational teams need to do on a day-to-day basis is look at the messages on the topics. Okay? It's not often they have to fix up, but they do occasionally need to look at that and figure out what the issues are. So what we've done, as I'll come on to a bit later on, is some of the monitoring platforms. But the spin back from that on the data sets is that you can't leave your data unencrypted. Okay? No public cloud is private. Even if Amazon says it is or Confluent says it is, there are always operators who can go and look at that data, triage your problems and all the rest of it, which is absolutely fine, right? They're managed services, which is good. But if you're dealing with PCI data, PII data, PIFI data, you've got to encrypt it, because otherwise your operational teams with the right tooling can kind of go in and go, oh, okay, that bank account or that bank account and so on. And obviously when you appreciate that we deal in financial services, we simply can't afford that. So message encryption was something we had to deal with from the outset. That caused us a problem because we had multiple teams, different parts of the globe, some running Java, some running .NET. You can imagine the interesting things with encryption on that one. You know, what's the common encryption standard and so on. That one was resolved, but it pushed the time envelope quite close. A simple one at the bottom. Are you going to have dependency in play or not? It's really a development choice. It's not a platform choice, but it does affect, the cost of config. What shouldn't be lost here is when you get into the nature of data, it costs. If you're going to host it in the cloud, it costs. So it costs to actually have the storage on the brokers. It has to, if you're going to replicate it somewhere else, you're going to have to duplicate that storage. The transfer costs, if you're going into cloud, which we were, that costs. So everything costs. So that data allocation, the data analysis up front, should we say, is a hugely important thing. And I wish we'd done it to start with, because it's something that didn't come in until after the first clusters were designed. The other team that I was mentioning actually were lucky in the sense that they had that data up front and able to start and run with it. Actually, the last point is worth mentioning. We have massive connections between ourselves and AWS, which is fine. When you're talking about large data sets, the transfer costs and the latency that can be introduced by the networks, if you don't have good connectivity between this, parts of your enterprise, is significant. So that's always worth considering right up front. I mentioned the external parties that we deal with. Okay, there's no way that our security teams will allow third parties direct access onto our clusters. Absolutely no way. So what we run with is an isolation and proxy layer, and that isolation and proxy layer effectively allows the external traffic to come in. It's a proxy layer which is isolated away from all of our other systems, and then we have effectively proxy applications that sit within that DMZ that proxy the external traffic onto our internal Kafka clusters. So when you're dealing with spinning up Kafka in a hybrid world, you can't just think about internal security. You've got to think, how do I take external traffic in, deal with it effectively? We also have, as I mentioned earlier on, due diligence systems. We have to push data out to those systems first and then grab the data back. And that then has to go back onto our Kafka clusters. So getting that security model right up front is hugely important. The WAF side, I'm sure is no surprise to anybody who deals with big system design. The interesting thing is that we actually use it internally as well as externally. We have some high bandwidth systems that sit in the States. And the concern when we started up with this system design was that they would flood all our topics. That was the concern, bearing in mind that we started small and wanted to ramp up the size of the product platforms we were. So what we use is WAF internally, Amazon WAF, to actually throttle back those internal connections as much as the external ones. The next one, authentication, is that security challenge I mentioned earlier on. If you've got a truly hybrid platform and you've got things in different clouds, what's the common authentication standard? That's a big, big challenge for us. Internally, I won't go into in terms of how we do it internally, but suffice it to say there are common standards for our internal systems for authenticating between different environments. The problem is that when you look at MSK and its offerings in Amazon, it's really good with IAM, their own authentication approach. It deals with SASL Scram, which is absolutely fine at Kafka levels. They've got OIDC interconnection, which is now coming in, which we're actively looking at. But at the end of the day, we've still got to somehow federate between the cloud and your on-prem systems. So you've got the same model everywhere. We did actually start with the aspirational MTLS type connection. The challenge with MTLS as a security standard is it relies obviously on certificates. The challenge of certificates in a hybrid platform is that you need a common CA, a certificate authority, to be able to manage those certificates and authorize them. Okay, how do you do that in a hybrid platform, right? So we talked to Amazon, they said, sure, we can do that, we'll federate with your internal security, your internal certificate management. Then we went to our internal security management guys and they said, not a chance. So we were left at the end of the day with a SASL Scram authentication model, which is not perfect, but it's sufficient for now, let's put it that way. Some of our other systems are all cloud-based and they use IAM, which is easier for them. But for us, it was it was a bit of a challenge though. And the bottom line one, to ACL or not, obviously on most Kafka clusters, you can put some level of ACLs in place just to avoid the privilege escalation piece. The challenge with that is when it comes to cluster replication, ACL can get in the way. So if anybody has configured Replicator in Amazon, you'll know exactly what I mean when it comes to authentication between clusters. That's a bit of a challenge. We've got the platforms almost built, but obviously what we talked about was that at the end of the day, the live operational platform needs support. So what we had to do was provide for support teams who didn't know Kafka a way to integrate with Kafka, be able to look at those platforms, alert on those platforms, and then actually interact at the simple level, the topic level, the user level, the schema level, to actually deliver the operational 24/7 of where the support window was for that particular platform. Now what you see here is one of the monitoring systems. It's showing one of our Amazon clusters. This one's actually monitored in the cloud-based system that actually monitors both our on-prem systems that are connected to this and the cloud-based systems. Okay, nice simple dashboard, nice and easy. And some people might even recognize what the product is we used to host it. So what we had to do here was build in operational knowledge of Kafka for the support teams. They actually didn't come on board until about a month before we went live. So you'll understand how close that was. They didn't actually at that time have operational experience with Kafka. They do now. But at the time, we had to build stuff for them. So what we see from the screenshot is really just that this interface provided them with the easy to manage Kafka. There are other tools to do it. For example, Kafka we use extensively. Kafka U is another good one, which I personally like to use, but nevertheless, what we did here was integrate both the monitoring of the platform with the command and control, and the ability to easily add users, easily add topics. How many topics, how many partitions you want on the topics and stuff, all taken care of. And as you'll see there, it works across multiple environments. What we've also factored in there, I'll just mention, is obviously the operational teams are not the only people who want to use it, the testing teams use it as well to go through the platforms. So now we're up to February 2023, we've got our pre-production second platform live on MSK, and we've got the drop-on monitoring, which is what I just showed on the screen now. The dev guys were an interesting challenge because they understood Kafka at the command line level, but not necessarily at the management level from a cluster point of view. They had their own Kafka environments that we built for them, but they didn't know necessarily how to manage those using the command line toolkit or anything like that. So once again, that was another environment that we managed to integrate for them. This is a development environment you're seeing on the screen. You'll see it's a Grafana dashboard, nice and easy, integrated into our monitoring framework. And it gives them the easy admin to go and create the topics to this piece for you. This one's a little bit different. Having got to almost the end of the journey, deployed our platform in AWS, we actually figured out that the sizing models weren't quite as we would like them to have been. They weren't as accurate as we needed to. So we looked at a number of different platforms, testing tools. We went through JMeter and Pepperbox. We went through test containers, Grafana, and other elements of smaller testing tools. But the one we actually settled on doing was actually building a small rig ourselves. When we did that, we actually found that the development environment that we've got, that we intended to support 100 TPS as max, is, as you can see there in the middle of the screen, this one's being tested at 500 TPS with a 10K message size, Jason's message, and you'll see it's supporting 492 quite happily. And at the bottom, the devs can see what their CPU usage is. There are other screens then to allow them to see what the memory usage is on the cluster, and we can monitor their applications in the same way. So it gives them one centralized monitoring framework that they can actually use if they don't understand Kafka. If they do understand Kafka, there's different ways of doing it. We supply with all of these development environments Kafka, so they can use the Kafka dashboards to come and go in and look at it. And that's a favorite tool, as we said, that we use for our operational platforms. So there's the timeline. April 2023, we got the production platform live in the 6 months that were requested, completed all the development environments, testing environments, and all the rest of them, the operational tooling, and so on. At that time, I would say we were on the first step of the Kafka ladder. I think we reached the second step, maybe. So what I wanted to just do was finalise with some lessons learned here. For us, the important things were identifying what we need from Kafka and what we don't need from Kafka. Yeah, we don't run KCDB, we don't use any of the other necessarily streaming effects and so on. We have basic Kafka, we write, to use as a message bus, we write messages to topics, and we consume them and so on. And that's really the model we've got at the moment. Having said that, the difference in systems that we've got is huge. The small one we built here to run 100 TPS is running quite happily. Okay, running on time. It's now been running since 2022, and it hasn't blipped. Okay, so fingers crossed. We have other systems that, as I said earlier on, now are in the 6,000 TPS range. That's huge. We have one of our financial systems over in the States that's running at 1,500 TPS every day. So, and it's scaled to actually run higher than that. The choice for us, importantly, we decide which cloud we want to run. Okay. If you're a hybrid the same as us, then you've got to consider what the lowest common denominator is. For us, it's a mixture of on-prem and AWS. But the connectivity is so crucial. It's so crucial. And the security model that goes around it. And as I've said repeatedly, that one on the bottom is almost the most important of the whole lot. Somebody's got to support it downstream. Somebody's got to have that Kafka knowledge. The thing that probably bent us most out of shape when we were actually building the system was the networks. It's all right to have a hybrid platform But how do you wire the things together? That's the problem. I mentioned, the wire protocol earlier on from a Kafka perspective, but that means that when you get into load balancing and so on, it's running at TCP layer 4, all you've got is poor host configurations. That doesn't work very nicely with a single point of load balance. So you have to consider those sorts of things up front. How are you going to do DR? Yeah, that's one of the big things. Are you going to do cross-region replication? Maybe use Mirror Maker, maybe use Replicator if you're on AWS. Yeah, that's fine. But your clients are then going to connect to it. And in order for your clients to connect to it, they need DNS. So another challenge, not related directly to Kafka, but in terms of using it, is how do you get that hybrid DNS working across clouds? And then last but not least, picking the suitable sizing model. I went through that. There's no real great ways to do it. The approximations you get can be good, and they can be out, way out. One of the approximations we got was for a 16-node cluster that is live in production with 3 nodes. So you've got to be very careful of those models and how you input parameters to it. And that's my quick run through as the warm-up. So, you can have it.
Thank you. Great presentation on a complex topic. Something I'm engaged with myself. Did I see Cassandra in there? I didn't think anyone was doing Cassandra. Was that your replace?
No. Cassandra's absolutely in the mix. We have moved the one system that was over here now to Postgres, but there's another requirement now to run Cassandra. The team I was talking about are actively trying to bring it in for another reason. So yes, we actively do use Cassandra.
Back to the future role. So what did you decide in the end? Cloud, on-prem, or hybrid? I didn't get
It is a completely hybrid platform. So it's a completely hybrid platform. So it's homed in AWS. So Kafka sits in AWS. But all of our clients are connected around the globe from different clouds, all on-prem infrastructure.
Okay. You didn't quite make that clear. Thank you.
Okay, pleasure.
Hi there. So do you have the customer in a single availability zone? How are you achieving HO? Are you doing like replication between regions, or how does that work?
Okay, yes, good question. So from an HO perspective, we definitely use 3 availability zones. There's no way we use anything less. We use server rather than serverless at this point in time, and it's across 3 AZs. So effectively, there's 3 real data centers in AWS terms. In terms of cross-region, we have a second region built out. There's active-passive, it's not active-active. So what we do is use DNS to swing from one region to the other, with a mirror maker replication between the 2. We did look to use Azure Replicator, which is a late kind of comes to the platform. I think it was looked at on Confluent League in that particular circumstance. But we had troubles with that because of the IAM setup. So the security model to allow you to replicate across proved to be a bit of a challenge for us. And so, yeah, ultimately we ended up with Mirror Maker 2 configuration.
Thanks very much. It was really great talk. You seem to have hit pretty much every problem you could hit and you're starting to grow, set something up very quickly. Which of those is like the networking, the replication, encryption, all of it, which was like the hardest one for you to crack?
Security, down security. The rest of it, all the plumbing and all the networks, we have lots of specialists in the organisation who can deal with that. We have good networking support on our own teams and things like that. The problem is security. Coming up with that common authentication standard and making it stick across all the different teams, down to the big one for us. When you combine that with message encryption, where they've got to use custom encryption libraries, and I won't go any further into how we do that, but nevertheless, they have to do that, build that into their code. Most of the developers have not seen Kafka, have not seen this particular encryption system. That was the biggest one. So dealing with the security of the platform, that was the biggest one for us across platform, no question.
Do you use Kafka for serialization?
Sorry?
What do you use for serialization? Is it Kafka?
Okay. You remember I mentioned the different teams? So some teams like to use Avro, some teams like to use JSON. Those are the 2 primarily used schema definitions, the serialization wise and schema definitions, I should say. So from that point of view, we haven't got one standard, we've got a number of different ones. We didn't think that we could constrain them because the problem is the teams work in a particular way, they have different backgrounds. So the major system tends to use Avro, some don't even use schema registry, it's fair to say. Some just compile, POJOs with the object definition, the class definition representing the message structure that they actually want to deploy to the platform. So yeah, that's how we deal with it.
We will have to replicate schema registry across clusters.
No, we put one schema registry, but obviously in the case of a regional failure, we would have to use the second region. So when we deploy a schema definition to schema registry, we do it to both regions at the same time. That's the automation.
Okay, thank you.
Okay.
Yeah, thank you very much. Really interesting journey you've been on. I try to follow along as much as I possibly did. I've got two questions. The first one is around just understanding how some partners that you work with from the service users.
Yeah.
How you convince them to accept or how to have communication for what is still a relatively new technology for financial organizations. And then the second question, following on the message about message, you mentioned understanding the size of your message. What are the consequences of the trade-offs you have to make about the size of the message?
Okay, let's deal with the second one first. I mean, the message sizing is the trade-off is around broker storage primarily, making sure that we've got that. It's about inter-region transfer costs from an AWS perspective, and also because we use Transit Gateway and that attracts data transfer cost, it's data transfer cost there. So message sizing is hugely important to us. Also, in terms of the sizing of the message hitting the broker, you're then into what is the throughput, the network throughput of each of those brokers. Right, so if you're hitting a particular broker and it's got a 250 megabyte kind of per second throughput, and then you throw 30k messages or 80k messages at it, a high transaction rate, you flood the machine. It doesn't have the bandwidth to take in the produced messages and then synchronize them across the cluster. The replication doesn't work correctly. So that's the implication of sizing. I mentioned earlier on also the other significant one is cost. The bigger you go with your messages, the more storage you need and the more it costs. And the first question was around, just repeat it if you don't mind.
Yes, security measures and
oh yeah, the external parties. Yeah, absolutely, thank you. External parties, there was an interesting one, but because we use an external isolation layer, we actually don't need to worry about them in that sense, because what they see is a REST API. That's all they see. So they come in on standard REST APIs. We isolate them, from a networking perspective within the DMZ layer, so it's all nice and secure. And then from there, the application in the DMZ takes it, that's provided the REST interface, I should say, and then pushes the messages to the cluster. So it's all synchronized in that particular way. When we've got an outbound, we just push a message out via REST API. So we've got an application that sits there, it's consuming from the cluster. When it gets an event it needs, that needs to go out to one of the other providers, it just pushes that message out using the REST API. Okay.
Thank you very much for providing some of the details. Just one question. Did you manage to come up with a solution for data discovery? If a developer was to find out who's publishing what, yes, can they do it or not? The second question is that you touched on ECL.
Yeah.
Did you mean that you implemented something like a role-based access or?
That last question's got lots and lots of implications. Role-based access is kind of interesting, really. At schema, what you do at the schema level plus the cluster or just the cluster. Okay. The challenge we had was when we do ACLs at the cluster level, there are limitations then on the scale we want to do replication. Okay. I mentioned earlier on the struggle we had with IAM and SASSTRAP. Okay. The ACLs piece actually was a further blocker on that particular problem for replication costs. It's fair to say that we've got the minimum ACLs on the cluster at the same time because the cluster is essentially all internal focus. Okay. We do isolate the teams to certain topics. So we've got a number of different teams that use the cluster. Not all of them as part of this system I've been describing. So there are other common template systems, if you like. For those guys, we create ACL specific to that, and some of those actually luckily do not have schema requirements. and then disclosure effect. So it's a scenario we haven't really come across yet today. So the discovery is that we've not had to encounter that problem, so I'm interested to catch up later on and find out what you've done. Our comp, I know Spencer can talk about it. But yeah, from that point of view, this will be a I have a good way. You mentioned end-to-end encryption, which is very interesting topic for me. Field level or field level. How do you do this how do you do the classification? So that's all done by the data architects. So in terms of what fields need to be encrypted or otherwise, that's down to them to actually define. So the data architects will say that field needs to be encrypted. I mean, this is what this one's right. Bank account details, personal information like name, address, that sort of stuff. Those fields have to be encrypted. But if it's just count data, transaction count data maybe, something like that, it's not going to be encrypted. So we have that mixture on top of it.
Okay, thank you.
Pleasure.
And we'll kick off in 5 minutes for the central.
So AWS, I cancelled it. They can get a reservation for not. Then you're getting over $40 million. They're going to buy a beer down there. I'm only going because I'm in town. I drive.
Yeah.
Good seeing you briefly. How are you? Good. Nice to keep me in mind if you hear of anything.
Yeah, we'll do.
I've got a funny feeling I'm going to have to go through networks as opposed to the fucking 100
Yeah,
CVs.
my boss told me that there was 230 people in the and I mean, I don't know if you can apply to it.
Oh, fucking no. I mean, you get a load of shit. But the problem is, if it goes on LinkedIn, you're only as good as the people looking at it. Yeah. If it goes to, I mean, I looked at every CV. If it goes to a recruiter, they're just paying plus their opinion, right? I know these things. They're fucking good guys. And I don't work with for a couple of years, so. So I'm here short. I'm going to get to sit short and get myself a guitar. Just the same falling out that you saw it there.
The nut job.
A lot of that, and then Rob just sat down. I was like, it's never going to work out. And to be honest, they're quite fast to me. Three now. Actually, can you take a bit whenever he sits down, take a picture of my friends over there? Back and down, back there.
We're going to kick off in a minute, so everyone take seats. Right. Conscious of the time, we've got to get kicked out at 8 it is. Yeah. The next speaker, I've actually known him for probably 3 or 4 years now. He's one of the only people that I would actually call for an SSL or security issue. We worked together on many projects. Brilliant to meet you tonight. Yeah. Sven, thank you very much.
Do I need the microphone? Maybe. All right, so thank you very much for the introduction. Some of you know me, some of you have worked with me. So just as a quick introduction, my name is Sven Erik Knoll. Most people call me Sven. I've been with Confluent since 2018, April 2018. That makes it just for 6.5 years, quite a long time now. I started as a solution architect, as though I have encountered lots of these problems that Paul talked about. Security was always a big thing. Deploying, where to deploy, how to bring it together, how to size the clusters. In many cases, when you, as a consultant, come in and size the cluster with customers, and they go, "We have millions of messages." I said, "Per second." They look at me aghast. "Look, per day. Use my Raspberry Pi. Go away." And then the customer comes along and says, "We have 5 million messages per second." We have a large messages. How many data messages? That's about 5 gigabytes a second. You know how many data we produce per day? Yeah, about 8 megabytes. Okay, we need a bigger hardware for that kind of thing. Bigger boat, if you like, go to choice. Anyway, so what do I do now? I work as a staff technical instructor, whatever that means. As part of my role as solution architect, I was team lead for the European team, for the PS team, about 30 people at that time. And my role was partially as well to enable people, to get them to learn the technology, make sure they're up to date with stuff. As part of that, I built boot camps, training courses, boot camps. And that kind of turned into an own independent role as well. So what's a bootcamp, you ask? Well, that's what you think of when you hear the word bootcamp, right? That's not quite what it is, not quite as military stuff. The way that I tend to explain a bootcamp in this game is compare them to a training course. So a training course, someone stays there, throws lots of slides on the wall, and afterwards you get a few sheets of paper and have to fill in the blanks. In a bootcamp, I give you a bunch of Lego bricks. I show you a picture of a nice house and say it's built up. So it's a lot more hands-on. The idea is you're going to get money. You're encouraged to make mistakes. You will make mistakes. And you learn those mistakes. If you go through and you build everything based on my scripts and everything works, then you haven't learned anything. You haven't tried out. You have no idea what kind of error message you get if you have a wrong comma in that in some places. So the bootcamp is all about getting things to work and understand how it interacts and how to set it up. One of my goals has always been to set up production environments. So as Paul said, all that's true. Or how do you actually spin up a cluster if you have to do it yourself? It's done with Terraform and Ansible. Confluent provides an Ansible provider. That kind of thing to run through. And then think about security. Security is the main topic of that. What I want to talk about today is not about this bootcamp, because I explained that. Who of you is technical in the point of view of DevOps spinning up environments? Who of you create stream environments? Kafka streams? You know, Kafka, of course, Kafka stream. Okay, so, that's the idea of bootcamp. Experiment, fail, learn. Okay. So, my goal is to instill confidence in people, because as many of these things, you gain confidence by doing it. You know you've done it once, you fall through, you've debugged it, you got it working, and that gives you confidence next time to go in there, the customer side and set it up. Usually bootcamps came because people heard of this word Kairos and they all panicked and walked away, because nobody knew what Kairos was. really about forgetting about the fact that they have used the Windows system before, which of course runs on Kerberos underneath that. The idea of Bootcamp was to teach people how to use Kerberos and not be afraid of it anymore. Once you've done it once, you might not remember every detail. You know you've done it. That's the kind of idea. Good. So, enough previously. Let's talk about this. I've been planning for quite a while now to build a strings bootcamp to talk about Kafka strings. Not just Kafka strings, but also KSQL or Flink talk about as well. With the same concept, help people to build this kind of environment. Kafka strings building. The very first example is very easy. The hello world example, we just read data of a topic, a stream, and then print it out on the screen. As soon as you go a little bit deeper, it gets a lot more complicated. And if you've never done that before, you're never going to wind up putting your hands up and saying, I want to help this customer. They have a Kafka Streams program because I don't know what it is. And hence, you never get experience with that. So the idea of the bootcamp is to give you some experience. So, Streams bootcamp. All right. Why? Well, the Kafka Streams is an appropriate way of dealing with lots of data. What would you do if you didn't have Kafka Streams or similar kind of streaming technology? Well, then you would write consumers and producers. You would consume the data and you would produce the data. For status operations, that's fair enough. Okay. When you have to deal about transactions and what happens if things go down, and the potency and so on, it might be a little bit more complicated, but how hard can it be? As soon as you think about state, that's a problem. Because suddenly you have to keep state somewhere on. You can keep it in memory, but perhaps the application goes down. You can write it to disk. Might take some time. Then you have to write the interface. So how do you do this? Kafka Streams is born out of the idea of being able to give you a possibility to do stateful operations by keeping the data in box.db and writing the disk automatically for you, the change log, so that you can deal with it as if it was an in-memory database, as fast as an in-memory database, without you having to worry about the details of it, just talk to the state store. There's a problem with Kafka Streams though, that's a problem in Java. So you know Java very well, or Scala if you want to actually coordinate within Scala. And then you have to somehow deploy it in Docker and Kubernetes or something like that. As an alternative, Confluent built this thing called KSQLDB. KSQLDB is a layer on top of Kafka Streams that does anything in SQL. But these days, no one that you speak to in Confluent will talk about KSQLDB, they will talk about Flink. Because we acquired a company that does a lot of Flink, and everything's Flink these days. I'm slowly being converted to that as well when I actually see the power of Flink and I need that might be going forward. So, all these things that I want to be able to support. There's supposed to be streams application in there with data in. Everything in our row. We talked about schema before. Do not ever use Kafka without a schema registry. I'm not just saying that because I work for Confluent, but we wrote schema registry, it's not the only one out there, but because as soon as you don't think about data contracts, you have to talk about something like schema registry. Kafka itself is schema-less. Yes, you can push a string in and pull a string out. As soon as things get more complicated, you're going to back to a schema registry. So my idea is I want to provide data in topics, in Avro, with a defined schema, and this data you're supposed to do something with and learn how to do Kafka Streams or something else on top of that. Then it's catch. Sorry. Start the overview first. So I have a Kafka cluster. I do this in a Confluent Cloud for reasons that you will see in a moment. I have a schema registry. I've got a few connectors to get the data in. I've got KSQL to process some data. And then your application is supposed to talk to that and actually do something with it. I'll give you an API key and permissions to access certain topics and to write to other topics, and off you go. That's kind of the plan behind this bootcamp in general. On the Confluent Cloud, there is a bootcamp organization, it's my organization, that sits in this environment. It contains the Kafka cluster itself, you can undo it. And that's how this thing is set up. So, the real question is, where does the data come from? Now, we've done this a few times. You can, of course, create dummy data. There are very nice data generators around. There are, a former colleague of us at Conference went off with his own company around to create generated data. The problem with generated data is that it is too clean. It comes to regular basis typically. It is all the reference integrity work just fine. It comes in a nicely prepared format. All this data in there has nothing to do with reality. In reality, if you build a stream application, you usually have to deal with data, things will be missing. You won't be able to join that over a certain period of time. There will be messages coming late. Some of that is a mess. Some of that is incorrect. You have to deal with all that around. And it comes, of course, in a format that no one can read, but you have to take the price apart. Okay, so self-generated data, yes, you can build tricks in there and make it obscure, something like that. Who's got the time for that kind of thing? I want a data source that I can use that has real data in it. Now, for a long time, we used Twitter. Or Twitter, as I like to call it. But Twitter, of course, is no more anymore. It's X, and it has a paywall. If you want to actually access it through an API, you have to pay for it. I'm not paying for that. Twitter's out. Any other data source you find out there to actually provide real-time data tends to do about Bitcoins. No, I hate Bitcoins. I don't know about you. All this stuff for me is all just pyramid scheme stuff. So I'm not dealing with that in any shape or form. I'm not understanding either. Is there no data source out there I can do something useful with, that I can actually understand, can I visualize? Turns out there's one. The network array. Now, who of you came by train today? Yeah, you all are very real. Have you seen the night sleeper? If you have, you built on the train, brave you. Lots of things that happen in the night sleeper, you recognize here again. It's actually based on reality. Anyway, network rail provides us with a free, that's the important part, access to actual data, real-time feeds. What real-time feeds? Well, every movement of every train in the whole of the UK. Every schema, every schedule of that, every location. That's what it is. It even goes so far and tells you exactly where a particular train is in a berth. Who knows what the berth is? I didn't. You know what the berth is? Very good. Okay. The berth is the space between two signals. Within the berth, you have one single train. If you have more than one train between the berth, you read about it in the paper next day, or you might have it as a breaking news coming up, because then typically you have a crash. So between space, each new berth is out on the line, lots of signals. Between that section is one single train, if at all. All these movements, or the state, or the statuses of the different signals are published. And you can get that out, and you can actually look at all the trains as they move around. So again, if you watch Night Sleeper and you've seen this fancy pencil panels behind that, I know the data that's behind that exists. In reality, we can download it. So it's freely available. It's real-time data of all train movements. There's some static feeds in there as well for some data that makes it sensitive, because it's all, it's not encrypted, but it's all reference data with some cryptic numbers. You can get that by simply going to that particular website and create yourself an account. You get the account ID back, and then you can go off and go to the data out via ActiveMQ. Very good. Data is published using a STOM format, a single text-oriented message format, but it's also accessible via ActiveMQ. ActiveMQ is the one I need. All right. All I need is username, password, off we go. What kind of data do we have then? Well, we have destination data, movement of trains. Coming into that particular station, it is 5 minutes late, 3 minutes early, that kind of thing. There's a lot more behind it, I'll show you a little bit of that later. They're actually all in one single topic in ActiveMQ, encoded via these types, 0, 1, 1, 2, 3, and so on. With train activation, whatever that is, train cancellation, we know all about that. But we're more interested in train movements typically, as moving trains around. There's also something like reinstatement. The train has been cancelled and afterwards reinstated again. That also happens. But the other ones don't happen that often. The data is batched. It's all jumped together in a big JSON object. So they have to be efficient. There's a lot of movement going on of these trains, as you can imagine. So it comes in a big chunk of JSON, batched up, hundreds of these messages together in one single block. That's one single block to get. Then you have to take it apart. Other data in there is TD, train describer messages. They can tell you where the trains are. You can funky stuff with that. Now, I live in a little village in Hampshire. In a little village, we have a train station. It's the reason why the village exists. We also have a train crossing. The train crossing used to cross its barriers down every, I don't know, maybe 15, 20 minutes. It's on the main line between Southampton and Reading, and we have lots of traffic coming to the harbour. So now that the down barriers are down every 5 minutes, and often they seem to be more down than they are. So someone wrote an app based on this data to actually tell us exactly which trains are moving around, just how long they have to wait there. Sometimes, yes, on this, so it's just dual track as in one direction each. Sometimes you have 4 trains going in that. It's very painful because it means you have to wait 10 minutes before it goes by. Well, the data's in here. In principle, you can take that out of that Kafka cluster, Kafka cluster, and recreate it again if you want to. Right. So why Confident Cloud? When I set out to do this, I wanted to not spin up any additional resources. Now, I live in AWS. It's not about I never used cloud before I joined Confluent. Ever since then, I don't think a day goes by and then have spun up something or moved something around in AWS. I've never done any of the exams in that, but I'm quite certain I could probably pass the first 3 of them. I've done enough stuff in that. So I know how to spin this up in AWS. And yet it's a pain. Particularly pain if you want to spin up services that then automatically download stuff. My goal I set myself, again, is that everything has to run within one single place, not spread out over many, many different services. I certainly didn't want to deal with Kubernetes because, well, it is not for the faint of heart. So Confident Cloud. What is Confident Cloud? Well, when we, Confident, set out and wanted to build this Confident Cloud, we had 3 mandates. We want to make it cloud native, we want to make it complete, and we want to be everywhere. Now, this is not a marketing talk for Confident or Confident Cloud. Yeah, don't get that wrong idea. It's just why I use this for theoretical purpose. Cloud native. What does that mean? You know what cloud native means? You take a service and put it up in the cloud, right? That's it. So you pay for the cloud services, networking costs, data storage costs, CPU costs, and you pay for the license costs on top of that. And that's your final cost. That doesn't work. You can't sell this as a service. It doesn't work. And especially with the Kafka clusters, they are usually oversized. You know, when you do the sizing experiment and build a Kafka cluster, these clusters are humongous. You could put them easily on 3 brokers on a Raspberry Pi, in the case that works. I have a demonstrator at home to show them. The problem is that you want to make use of the fact that cloud is in there. The cloud is all about scalability. It's how AWS was invented. Actually, a group of people in South Africa working for Amazon had to spin these machines up all the time. They got bored with it and came up with a system to kind of do this as a service. So you want to be able to spin this out and make this scalable in the point of view that you share as much resource as possible. Confident Cloud does that. The types of clusters in there that are shared by thousands of other users. You don't know the difference. You get your guaranteed benefit. That's all you're interested in. There are also dedicated clusters, but the cloud native part underneath that and the technology you can read up in the paper called Quora of how much it goes in. We claim on that paper that we're 10 times faster than native Kafka. And we have tested this to the nth degree, and our customers have as well. It's actually true. Anyway, complete means everything, every single service you need is in there. Flink is kind of the dotting of the I or the dashing of the T sitting on top of that. Actually, not quite sure iceberg will be, but we'll get into that later. And everywhere, in every single cloud, so Azure, AWS, GCP, in every single region. They come in different cluster sizes. Basic, standard, enterprise are all shared clusters. You can also create dedicated clusters as well. They take longer to spin up and they cost a lot of money. But then there's all kinds of focus with private networking, which is a big deal of what our consultants these days do when they spin up clusters for customers. Right. Enough talk. What I need for my bootcamp is a standard cluster. A standard cluster is spread over 3 availability zones and delivers 99.99% SLA. You know what that is? You know what SLA is, but what is 99.99%? How many hours per year? Not the FOPS deal after 4 hours per year. In reality, it's much better than that, but that's kind of the big area. I have RBAC, role-based access control, so that's what I use for authorization. I don't use ACLs. I don't need any private networking, which is great because that would mean I have to spin up other things. I want to keep everything in one single place. Region, configurable AWS or West 1 is the way I start the first one up. I tend to live in Ireland in that respect, but you can spin it up wherever you like. The Streams government package these days lives together with your cluster. It used to be in Frankfurt for Europe. That has all changed. Some of the slides need updating with that, but my script's already updated. I will use connectors to pull the data in KSQL the process step. Why KSQL we'll do that afterwards. All right. My requirement for everything is infrastructure as code. That's what I live by every single day. That's what I teach all the people I train with, internal partners and so on. Infrastructure as code. Do not touch anything by hand. Everything has to be done through script. Why? Well, if you ever done something by hand like this, keeping a production cluster up and running by hand, then you know why. Because it will blow up. You won't be able to follow through what actually happened. You can't reproduce it again, and so on and so on and so on. Mantra is infrastructure as code. Which probably makes you think in the moment that I work for HashiCorp and not for Confluent because I know all about Terraform. All right. I don't want any external dependencies. No external clusters, no Kubernetes, no nothing else spun. One in one single place. Right. So for that, we need the Confluent Terraform provider. Use the Confluent Terraform provider. Who of you does not know what Terraform is? Yay! Terraform is a script to start things up, to build infrastructure. Terraform itself is stupid. It can deal with variables. It can deal with a thing called a provider that it asks for things and gets things. It can deal with dependencies between the different things. That's all it can do. The providers are the interesting part because they do the extra work. The provider for AWS actually talks to AWS service and spins up the clusters. The provider for Terraform, for Confluent, talks to the Confluent API and then says, I need an environment, I need a cluster, I need a schema registry, I need topics, and so on. So that's what it does. Everything here, everything exists you can access to the API, you can access via Terraform. I go so far that I tell the people who actually do the development for that, it's not Terraform, it doesn't exist. I don't actually touch the API, the REST API, I only go to Terraform. It doesn't exist in Terraform, I wait until it exists or make a lot of noise so that it exists afterwards. Well, with one exception, you get that. The problem with applying Terraform, by the way, is it changes over time. About every single week or something like that, but a new version there because Confluent Cloud changes so often. I do this because it's repeatable. I can spin it up in one place. I can make the changes in my script and then just spin it up to see where everything works. That's kind of the goal. Press button, okay, Terraform apply, and everything should be running. No human interaction. So, all right, some code example. There's a bit of code coming up, but mostly Terraform code. So Terraform itself, if you have code program Terraform itself, is with the language called HCL, actually, besides HCL2, which is the HashiCorp command language. It looks a bit like JSON, but without the bloody quotes all the time. Instead, it's just key with value and brackets around. For the record, I love Python. I hate YAML. Go figure. YAML is double spawn. Writing everything in YAML It's just, if you have to merge things together with other people to put YAML in there, and then you get the tabs with spaces wrong, and everything blows up, and you don't know why. That's how I got my gray hair. Brackets, life is easier. Anyway, so we have Terraform, a required provider. I have not updated this slide. The new version at the moment, I think, is 2.40 in that. So it comes from Confluent Inc. Confluent. So there's a Terraform hub where these things are stored, and then afterwards you just download it from there. The provider you configure, in my case, I configure them with the API key and the secret, what that is in a second. I spin up an environment, I spin up my cluster. So that's what the Bootstrap cluster is. You can see down here, it's a standard cluster. How long do you think it takes to bring the cluster up? Any guesses? About 5 seconds. So if you bring a cluster up by hand, as I do often with my poor students, that takes about an hour the first time. So then after you go to Confluent Cloud and press the button, and there's the cluster. That's why it's shared. Right. Okay. You need to feed this thing in somehow. You need to feed it with a API key and an API secret. These are 2 long strings, and you have to insert them, inject them somehow into your script to make this whole thing work. Now, whatever you do not ever store those key and secret in your Terraform script and then upload it to GitHub. If you want to have a laugh, go and look for those kind of keywords in GitHub. You find lots of examples of this. Might not be the safest thing to do. I inject them by environment variables. In my case, because I use dirinf. Who knows what dirinf is? Hey, fantastic. So I use dirinf for that, so I inject them automatically in that way. You can just run the script beforehand to get it up and running. Okay. Comes in very handy. So you export the variables, and you on Terraform apply, up everything should be running. Good. We have a cluster. Fantastic. Now we're going to feed it the data. How are we going to do that? Train movements train scrubbers exist as active MQ resources. All we need to do is provide them with the right place where we're going to talk to it. User and password, going to be another one of these passwords we inject. And then, sorry about the color, I hope you can read it. The details are not really that important. The important thing is I can configure the connector using Terraform. It runs as a so-called managed connector. It means Confluent Cloud will run the connector for me. It will talk out to that endpoint to provide, and it will pull down data in whatever format this comes from. Can you specify, like I have it in Avro, please? I want to configure the whole thing with another principle. So everything should be infrastructure as code. The other principle that I like to follow is the principle of least privilege. Least privilege, in this case, security. I only give it as much power to write the stuff as necessary. So there is a user here that has exactly the permissions to write those particular topics around the data. That's it. Even if someone gets hold of that particular user and the API key, they can write the topics, nothing else. Good. All right. Now, all this data is useless. It talks about lots of numbers for positions. It talks about schedules in some shape or form that you don't have any reference data for. You need reference data to talk to this thing. Okay, where do you get the reference data from? Well, there are 2 different types of reference data. There's static data, the train or recurrent talk. You remember that name from Nicely, I assume, because all of them talks. The train or ring companies, the locations, cancellation reasons, and so on, these are all things that are static. Well, maybe not the current government, but we shall see how long the companies survive. But in principle, they are changing very rarely over a long period of time. Locations don't tend to move around. And cancellation reasons, they have come up with 1,000 different reasons. I think even that may be sufficient. So then it changes very rarely, if at all. So I can just store it in my project as a CSV file. I see it's acceptable, it's stored within my Terraform script. I just have to find a way of uploading it, get to that. And then we have regular screen changing things, schedules. Schedules change every day. Actually, in reality, schedules change more often than that. I already do every day. Every day, a new change to the schedule is published on another of these endpoints given by our data guys. Never read. It comes either as a huge file or as delta. Now, delta is great. Alas, specifically with KSQL, delta is a pain because sometimes schedules get deleted and then rebuilt again. And KSQL doesn't work very well with deletes. It would have been very painful to put that in. So I bite the bullet and download the whole big file. The whole big file lives in S3 with an endpoint you can talk to and download. It is compressed JSON. How can I put that into my application as part of infrastructure as code in one single place? That turned out to be tricky. For that, I had to write my first own connector. I've been only 6.5 years in Confluent. This is the first connector I wrote myself. So there is an HTTP connector out there, actually, called the Cloud Managed Connector, but it couldn't do decompression. It was dealing with 2 gigabyte files. So I wrote my own connector. The source code is here. Everything is in my GitHub account, GitHub/sglow. So for loading up the data, it comes in CSV format. CSV is easy, right? Well, except some of them need commas inside, so you have to occasionally swap around the commas for a slash configurable. How do you load this up? Point my Terraform script to a file and said load this up into the Confluent Cloud. And I want to create the schema for that automatically. So the first line in that CSV file is supposed to contain the schema information, which I then deduce the schema and generate it automatically. Turns out there was no tool available, so I had to write it myself as well. Without you can see that here. So the CSV file uploader loads the file up, splits the cost separators, uses a generic alpha provider to feed the data in, first generates the schema beforehand, because that's the first line. I can deduce the schema from that, identifies which key field of that is the key, and then uploads the data. It goes to the compacted topic because it's reference data, which means that I have to identify a key beforehand. And then we have our regular changing data. So on S3, a file is uploaded at between midnight and 12:30. That is several gigabytes in size and has compressed all my schedule as well as all location data in it. The locations don't change that often, but they're published anyway. Delta is a pain, so I'll load everything up. All right, so I wrote a connector, a source connector, called HTTP compressed source connector. That goes and first of all checks the header. So in S3, if you publish something, the header on that particular website will tell you how big the file is and also tell you the timestamp of the file. So I have to keep track of the timestamp, find out whether it has changed, and poll this on a regular basis, every 5 minutes by default. See whether it's changed. If it has changed, then I upload the file. Don't upload every single time I connect it. It's gzip compressed and then contains JSON. Okay. Now, this is a managed connector, lives within the Confluent Cloud. I can't just upload a 2 gigabyte file, then uncompress it to 10 gigabyte or whatever size it is, and have to load in there because it'll blow up. It has a very limited amount of memory. So I need to build a stream. It goes HTTP into a GC uncompress, into the feeding the data out there line by line, into the then generating a certain amount of data for that, and then send that off in that. That took a bit doing back and forwards at that. And it's quite ugly code, as in this three for loops into each other. So if you look at the code, please don't judge me by that. But it does all that and keeps track of the all-important offsets, the connector offset as well, so that I can restart again if necessary. Pulls the stuff in and works. This has been working in the background for over a year. Every single day it downloads the data. I can look at the log file and see the spike coming in there. It does its job just nicely. So if you ever look for that kind of code, feel free and grab it under Apache license. Right. So how do you actually write the connector? If you've never written a connector before, it has three main classes. It has the connector itself, which has to be extending source connector. We have a configuration. It's configuration stuff in it, so that's what you put in if you configure the connector. The configuration has to be stored somewhere. This defaults and obviously. So that's the job of that class. And then finally, a task that does the real work. The first one just glues the other two together. So that one's very simple, always the same. That configuration file depends on what kind of configuration you want to publish. And finally, we have the task that actually does the real work. And the real work does one single method that pull. It's called on a regular basis. And then internally, it pulls some data off, in my case from HTTP, and then writes some offsets of the data out, and then goes back again after a while and gets called again on a regular basis. And that's what you do. There's a stop in there as well, just in case you want to interrupt the number outside. I've tested this once. Yes, it does work. But in the Config Cloud, I don't need to bother about that. Good. Now, how are you going to get that connector in there? Wait a moment. I said we're running Config Cloud. We're running managed connectors. How do you get this connector up there? Well, it turns out that sometime a year and a half ago or something like this, we opened the possibility that you can bring up your own connector. You can upload your own connector. And more importantly, because otherwise it wouldn't exist, remember, I can do it on Terraform. So I can specify, I have a connector plugin, point it to a jar file, then upload that connector in there, configure it correctly so that I know exactly which parameters I have to put in, including the one important where my password is stored. So you can't see it when you look in the Config Cloud itself, my password popping up. And then all I have to do is to configure the connector based on this, on the reference to that. And then I have to explain it that it's a custom connector. It comes with a penalty. That custom connector has to open up certain ports. I have to explain it to the custom connector which particular ports I can actually talk to. The Config Cloud doesn't let you just put something up there and then happily download all kind of Bitcoin information. You have to actually specify in the UI which kind of endpoints you would be able to talk to. That's how I found it was actually S3 stored, because the original HTTP that gave me afterwards pointed to the S3 bucket, and I need to put both of these addresses in, otherwise it doesn't. Good. Okay. I have my reference data from two different sources, local data that I have in a CSV file, several actually. I have the uploaded data that comes every single day. I have the data coming in from my ActiveMQ, all ready for the bootcamp, right? Now, that would be unfair. The data is utter mess. It needs to be kind of put together. So I want to prepare the data somehow that people actually use it. And that's KSQL. Now, why is it KSQL, not Flink? Two reasons. The first reason is when I started this, Flink didn't exist. It wasn't on the radar. The second reason is Flink, in the way current form it exists, doesn't work for me. I am in the middle of migrating it, but it takes more work for one particular reason. Right. What is the message that you get here? Well, if you look in the website of the National Rail, try to decipher what's going on there, you're going to be very confused because it talks about lots of abbreviations and other bits and pieces, and it takes a while to figure out what the hell they were doing there. What it turns out to be is that a message I get, it's one single block from ActiveMQ, contains, first of all, a huge chunk of metadata in JSON. It then contains a big array, a JSON array. That JSON array itself contains hundreds of messages. Each message itself also has a header, and then the actual payload data I'm interested in. Hundreds of messages in an array in a single message, which you have to take apart. That's easy. I just use Jackson, right? Yeah, this is how am I supposed to run Jackson in the Config Cloud? It doesn't work. So I need to pack this out. That turned to be more complex than expected. Now, here I have to give credit to Robin Moffat. Robin Moffat is a former developer advocate and presenter for Confluent. Now long left, unfortunately, because he tried to drive something different. The original idea of using the national rail data and the original KSQL queries and put the stuff apart all came from him. Now, he's a data scientist. He knows how to deal with data. What he is not is a DevOps engineer or someone else that goes from cloud. It is an opaque of Docker images and bits and pieces flying around, and you have the run application on this screen and application on that screen. It's nothing you can just give to people and then run this. I'm more of the DevOps kind of persuasion. I'm not a data engineer, as you will see in a moment. So I can build the infrastructure based on his original ideas, clean it up and make it in one single line script. So KSQL, if you've never seen it, looks a bit like SQL, with these funny create stream things in there that actually just map out a topic as a stream. And explain which well format to come in. And then I have to price them apart. That turns out to be not so easy because the data in there is in JSON. If we want to speak Avro, how are we going to convert one to the other? We have to extract particular fields from that and then kind of put them in there. The trick is to interpret the whole thing as one single string and then use this merge method. The next slide, I think, extract JSON field in there to go and pick and pull the JSON fields out. This is a hack. Now, Flink is much cleaner than this. If I could use Flink for this, I would. Promise. Flink has all the JSON methods built in a much cleaner variety. The only thing Flink doesn't do is explode. So you can't take an array, get in the middle message out, and then afterwards put them as individual messages in our topic. Yes, of course, Flink has explode as a method. It's not called explode, cross something. But that only works on Flink arrays. What it doesn't have is a method to take a JSON array and convert that into a Flink array. That's the part missing. That's the reason why I still haven't converted that. I can now use UDFs, but for that I have to write them first. UDFs, user-defined functions. I can plug them into Flink and then make them. Okay. So, here the magic cast in there. So the body is Flink. So there's all kinds of these messages in there. You have to take all this stuff apart, so that you or whoever actually wants to use this to write application doesn't have to do that. You get a nice clean Avro, nice clearly described each individual fields in there with proper data. Right. Here's where things get tricky. Everyone loves the graph model, especially if things point backwards. See, these trains don't move by themselves. They get kicked off. They have a schedule that says this train is going to move from Glasgow to London Euston via these stations. That's fine, at this particular point in time, every single day. Hopefully, not winding up Victoria. But it doesn't mean the train is leaving them. The train has to be activated. This can happen automatically, or this can happen by someone actually going and putting the flag in there and saying the train is not finally left, in case the driver was asleep or drunk or whatever. So we're looking for that magic activation first before we can do anything else. Only the activation is connected to the schedule. So what I'm after are the movements. Movement of the trains around, potentially cancellations as well. They don't exist in the background, they have to be linked to the activation. If you paid attention a little bit earlier, you've seen that the activation and the train movements and the cancellation and the reinstatements and everything else is all in the same data package. So I need to kind of do the Munchausen thing of pulling myself out of the swamp with my hair by getting the activation, find them first, and then try to retrospectively activate the train so I can then move them around. It is for that reason that, yes, the whole environment spins up in 5 minutes, but it takes about half an hour to warm up before the activation is filled up enough that they actually can activate the trains and run with that. So if you ever want to use this and want to demonstrate it, then start it the day before. All right, so movement, link to activation, link to schedule, link to location, schedule location in there. Some movement data as well. So the data model here gets a bit complex. I said real data looks messy. It certainly does here. Lots of things going around, lots of state transitions going on. The train actually finds stuff moving, getting somewhere, reaching a station, and finally reaching a final destination, in which case it then terminated. So that's why I have to spin this up slowly. Right. Next problem. KSQL is nice. So how do I teach the Conflict Cloud about KSQL? That's easy. You say use Terraform script. Yeah. Now, see, KSQL never made it to Terraform. The very time that engineers were out there and had in the task list, oh, we have to buy a Terraform provider for that, Flink came on board. For Flink statements, you can just simply write them in Terraform, you can write the statements out there, beautifully set everything up, everything works beautifully. For KSQL, no such luck. So we have to write it ourselves. Hey, I wrote all the other things, might as well write that one as well. So KSQL uploader came along. There is some APIs available in our library, publicly available, that you can use to bring KSQL up and teach Terraform to talk to it. There's a slight catch. See, who of you use GitHub? Shame on you. My original company I came from was called Perforce. They provide a version system that can deal with lots of data. Lots of data, I think, they are used in the gaming industry. Any idea of what a AAA game is? Who's a gamer? One single person admits to that. You all game. Come on, don't tell me this. I know you do. So, AAA game, how much data you will store in that? Have a guess of how much the source code for one single version, how much space it uses. One single AAA game.
Right.
Not quite, no. Not far, but 2 terabytes. 2 terabytes data, the terminals thing in there, all the, not the source code. Source code is tiny. The images, sounds, videos, textures, and other bits and pieces all together, one single layer up. Not all together. It's compiled to multiple stages on use compiled files afterwards. Turn it into 25 or 50 gigabyte download if you want to get, if you download the game like that in there. Now, every single time someone makes a tiny little change, the whole thing gets compiled again, built again, a lot of stuff. So that's kind of world I grew up in. Then they come to GitHub. What's the largest file you can upload to GitHub? Any idea?
Gigabyte?
Ah, dreaming. Not quite as bad as that. 100 megabyte. 100 megabytes largest file you can upload. Yes, you can activate Git LFS, large file support. I have looked, working at Perforce, I've worked many times with Git LFS and had a terrible laugh about it and said, yeah, but to use that, shoot yourself first. And it's definitely the case, it is horrible. You also need to pay for GitHub if you ever want to use it beyond one single file. And suddenly, if you enable that, everything is enabled Git LFS, and you go over that one file limit very quickly because all the other files in there are also in there. So as soon as you use it, you are hooked on 10 or 15 pounds a month. Some of this in GitHub. No guys, not a chance. Especially not since they bought Microsoft. So whoever wrote the KSQL uploader, whoever wrote the library that used the KSQL uploader, decided to bring the whole internet down. If you actually spin on Maven, it loads and loads and loads. Then when your hard drive is full, then and only then we start compiling, making stuff together. The end result of that was 150 megabytes of size, which I couldn't upload. So that's a problem. I don't want to spin up, every single time I do this, I want to spin up Maven and spin up this jar file. Turns out there's an option in that where you can go through and filter it and remove all the stuff that don't actually need use in that kind of thing, which turned to be quite a lot. Put it down to 85 megabytes, I can upload as a single file. So the uploader is in my Terraform script and actually runs nicely with that. And then you can set up a local execution of that. Yes, I think I require Java to be around somewhere. That's the minimum thing I have to have in place. All dependencies, and then it uploads a thing, and then I point it to my KSQL directory, and it goes to every single file in that, and executes from one after the other. Okay. For waste of time, and because I don't have that much and I can't reach my computer, I will spare you some example analysis. Just one tidbit. You get location data. Location data comes with grid reference. Longitude, latitude, where the stuff is. The curious person in me goes and says, well, what happens if I take this location data and then send it to Elasticsearch? And I use a wonderful mode where I can plot this onto an image of the UK. There are about 11,000 locations on it. 10,000 of them are roughly where I expect them to be. And about 1,000 of them are in the middle of the sea. Now, I have looked long and far. I don't think I've ever seen a station out there on the sea, but some of them are very close by, I have to say. but in reality, that data is dirty. And if I ever get time for this, and cost of time and some of this, I will go to the data and find and actually fix all the data in there. Someone has uploaded the data and hasn't quite paid attention. I'd love to send a picture of that and say, are you sure that's really there in the middle of it? Is that the station of Atlantis or something like this? So you can do this kind of stuff. All the data you need is in there. All the different kind of train companies in there. You can find out which train companies are on time, which train companies are a bit late, which train companies are very late, which train companies cancel a lot of stuff. These are very simple queries from craft. You can find out whether your local train is on time or not. You can hook this up. And Robert Moffat done this. He hooked up to Telegram, sent a message out of Telegram that actually sent him information about whether this train is coming late. You can show your local schedule of everything that happens on your home station. Apparently, it's not that interesting. This is 2 trains going each way between Basing and Reading in either way. That's it. 4 trains plus lots of freight trains and express trains and non-stop there. So it's not that much there. All the stuff you can do. This is for my students to figure out. So given examples. The idea, of course, is to learn how to access write Kafka Streams applications to read, build tables, to deal with schema changes, to deal with scalability, and so on and so on. So, in conclusion, sorry, I'm slightly over time. Actually, I'm quite good. I have a record that's talking half an hour long now. So, the infrastructure as code. That's a good thing. Trademark sign. I create an environment, a cluster, schema registry, a SQL DB cluster. I create topics, I create service users, I create permissions to access this stuff in there. I upload custom connectors, I get those connectors up and working, I upload started data. Everything runs within the Kafka cloud. I have no idea how much it costs. It's cheap. One day, someone will come after me and go, "Oi, you've been running these resources there. Are you bit mining or what are you doing?" One day I have to explain myself. But currently, it runs under my budget as a test environment. English controller runs there. The KSQL series run there. They will be replaced by Flink once I got Flink up and running. And yes. And egress I've put egress out to Elasticsearch. Now that one I have to spin up. I can't run the content out. I can point it to Elasticsearch and go, yeah, have some data. Let's see what kind of answer we need. So expect signups for this webview. The course is not ready yet because I've been pulled off all kinds of other services all the time and running training courses and building other things. This is kind of my hobby at the moment. I can convince someone this is important. And at one stage, it will be hopefully a course. I can run this for partners, maybe even publicly. But you can download all the data, you can try it on yourself. You can use a Kafka Cloud account and go. And that is all she wrote.
Any questions?
Does any of you know Eliezer? Eliezer, anyone?
No, not personally.
You ever seen a sketch with Darth Vader in the canteen? He nods, yes. So Darth Vader in the canteen. Put Eliezer, Darth Vader canteen in there. He does this conversation. And I've been kind of thinking of what would I do in case someone asks questions. Because I go, here's the question person, here am I answering the questions. So what about Flink? What about Confluent? Whenever you talked about them, Flink is the future. Why are you talking about KSQL? That's a multi-layered question. First of all, as I said, KSQL was there before. Flink didn't exist by the time I set it up. Second, KSQL can't deal with JSON messages, or it can't explode JSON messages. There's a problem. I can write UDF functions. But when I tried out Flink the very first time on the stuff I built in there, I came across my rather wild Avro. Avro is not just flat file, something like that. It can be very convoluted with lots of AIs in there and referencing other bits and pieces and so on. Avro there is quite wild. Flink just went and died a horrible death. So I wasn't really convinced it's the right thing. Nowadays, I can run a thing query over this without any problems. I can deal with it proper. But I couldn't to begin with. I'm learning Flink, okay? As fast as I can. There are horrible hacks in this case with stuff. In order to take the data apart, I first have to convert it into first the strings, and then into JSON, and then again in JSON, and then finally into Avro. That goes to 4 different topics. The data coming in there, about 25 kilobytes a second, has to jump into 4 different topics 4 times the cost, and of course the timing as well. I'd rather do this in one single statement. I can't, it's equals 2. But it works. Flink does not, until I teach it part. Then convince the people that, and talk to them, the people that actually have the power to make the changes. To put those fixes I put in there, so you have into the code itself. So convert JSON to Avro, please, as a cast. Thank you. It'll come. Now, when you go to our website, if you look around, you get exposed to our marketing material, who you, if you do, all they talk about is shift left. Shift left mean? It means don't do the analysis after you pull the data into some data sink or there. Cassandra, God knows what, in there. Do it before, within the Confluent Cloud. Why? Because otherwise you do it multiple times. Doing it on a database, in dashboard, is most likely not going to be as efficient as doing it within itself. That's what Flink is for. That's what Iceberg will be for as well. Provide you the table formats, everything ready. All you have to do is just pull the data off and treat it like a database. And then you're done with that. I'm fully behind that idea because every single time you cross the boundary, you got to support. Every single time you do a network in and out of AWS or any other providers, it costs you money, a lot of money. As long as you keep anything within this thing, it is actually cheap. If you store the stuff in a cargo cluster, whatever we call them freight clusters now, also S3 if you don't care about latency, and that kind of thing, you can do it also very cheap. So doing all the processing within the Confluent Cloud, this is what they do. This is what this is all about. There's no external source, no external dependency. Everything is done in there. I'm not sure if this is the final answer to everything, but it's certainly going in the direction of what the company Confluent is doing as well. Moving that direction. Okay, enough.
Cool. Thank you very much, sir. Thank you very much for that. So we've got 5 or 10 minutes to the quick out, so yeah, thanks for coming back. Cheers.